Okay, this is the P3 paper from January 2021. This is question number 5, which is an exponentials and logs question, but more specifically, as you can see, exponential modelling. So, always important to have a good read through of it. You can pause the video if you want and then carry on. But basically what we've got with this one is the temperature of an oven is theta, and T is the amount of minutes after the oven has turned on, and it's modelled as this negative exponential. It says for part A, given that the temperature inside the oven initially is 18, can we work out what A is? Well, yeah, we absolutely can. This is a relatively standard start to one of these sorts of questions. So for part A, we've got that theta is equal to A minus 180 e to the minus kt, but then because they tell me initially, they're telling me that theta is equal to 18 when t is equal to 0. So if I put that in, I get that 18 is A minus 180. It's e to the minus kt, but because t is 0, it just becomes e to the 0 there. And obviously we know anything to the power of 0 is 1. So that's 18 minus A minus 180 times 1. So from that we get that A simply works out to be equal to 198. So that's the answer to part A. And obviously for the rest of the question now, instead of having A, we can have 198 minus 180 e to the minus kt. So that now becomes our new constant. And then what they're going to do for part B is probably, let's have a look at it. Temperature inside the oven 5 minutes after it's switched on is 90. Yeah, so I've now got on that one, I've got T is 5 and theta is 90, and they're going to ask me to work out K. So it says, show that K is equal to P log Q, where P and Q are rational numbers to be found. Okay, let's go ahead and do that then. So I've got T is equal to 5 when theta is equal to 90. So put that in. 90 is equal to 198 minus 180 e to the minus 5k. That will become. And now all I need to do, well, not all I need to do, but I need to rearrange and make k the subject of that. Do not try and log to, we're going to log both sides at some stage. Don't try and do that too early. Let's do all the easy IGCSE bits. So first thing I can do is 90 minus 198 is equal to minus 180 e to the minus 5k, which means minus 108 is equal to minus 180 e to the minus 5k, which means e to the minus 5k is minus 108 over minus 180. That actually works out to be 3/5. So that's sort of where I was trying to get to, so that now I can log both sides here. Okay, if I log both sides at this stage, then I'll get rid of the e, and I'm going to get minus 5k equals log 3/5, which then gives me that k works out to be minus 1/5 log 3/5 here. And if we then go back and look at what they asked us to have, they said, first of all, in the question, where are we? Because I've been looking out for this, that k is a positive constant here. And if I want it in this format, k equals p log q, what I just need to do, and I've done this on previous questions, go back and look at my other exponential and log questions. You'll see this technique used before. That I'm basically using the idea, well, let me tell you what it is first of all. That's the same as 1/5 log 5 over 3. Okay, I can take that minus there and just flip that one upside down. Remember that log of A minus log of B is log of A over B. So if I just flip it upside down, we know that log B minus log A is log B over A. But this one here is the negative of this one here. Okay, so log A over B, if necessary, is always minus log B over A, and vice versa. So they use that quite a bit in the exam, but you might not have had it in your work as you were going through, but it's one of their favourite little tricks when we're doing these ones. So yeah, just to make it clear, that's my answer for K then, a fifth log 5 over 3. Okay, on to part C. What does that ask us to do? So part C says, hence, so okay, once we've done all that, find the temperature inside the oven 9 minutes after the oven is switched on, and give the answer to 3 sig figs. So again, just remind myself of that at the end. So part C, that's going to be theta is equal to 198. And again, just quickly, so we started off with the equation being that where I had A and K. I've now got the equation being that where I already know what A is, but now my equation will be where I've got A and K, and everything else that the only variable we've got now is going to be T here. So it's 198 minus 180 e to the minus kt, so that's to the minus a fifth log 5 over 3. That's all a constant times by t here. Just think about the way that you're setting that out, more just so that you don't make any mistakes and anything when we're actually going through and doing this. So that's my equation, and we just want when t equals 9 in here. Okay, so theta is going to be 198 minus 180 e, and then 9 times all of that is going to give me 9, or rather minus 9 fifths log 5 over 3. So you've just got to use your calculator skills now. I can't really show you that on the video here. Plug all that in, be really careful. Comes to 3 significant figures, 126 degrees. And again, make sure that you remind yourself of going through and doing all that. Always go back, and that's why I got it underlined there to remind me at that stage. I don't want to lose a mark for the last bit. Then part of D says, can we find the rate of increase of temperature? That's a nasty little bit at the end of this question, isn't it? But what they're basically saying then, if I've got theta is equal to, and do you know what, I'm just going to use my iPad to copy this thing out because it's a pain to keep writing it. Theta is equal to that. Rate of increase is d theta by dt. So d theta by dt, differential, remember if we've got e to the, let's just say minus 2x, what that's going to become is minus 2e to the minus 2x, don't we? We are multiplying by the differential up there. So here then we're going to have, the 198 goes obviously, I'm going to have minus 180 times by minus a fifth e to the log, oops, sorry, I'm even getting myself into a tiz there, sorry, minus 180 times minus a fifth log 5 over 3, that's the constant, e to the same thing, minus a fifth. Goodness sake. Log 5 over 3 t. And you saw how many mistakes I was making just trying to copy that all out here. Just stop and look at that thing before you're putting t in. Just make sure that's exactly what we wanted to have. We wanted, oops, excuse me, that multiplied by that, which I've got here, and then keeping the e to the minus all of that the same. And then you're going to put t equals 9 in here. So again, I'm not going to bother writing it all out. Plug it all in, and hopefully it should come to 7.33. Don't forget to put the units on. Go back and just check what we've got going on here. Again, it did say 3 significant figures, and it says degrees C per min, degrees C per min. Yeah, some nasty little bits to that question, but overall the knowledge should be okay of it. And just make sure you've practiced these ones, so some of those little tricky techniques, that they become a little bit more like second nature to you. Okay, hopefully that makes sense.